All right, in the last video, we set up this problem where we had 10 slope fields and we wanted to identify the differential equations that generated each one of those slope fields. And so what I want to do is kind of go through these kind of in a staggered order and come up with the way that I solved the problem. And you can see if you got the same solutions as me, and if not, hopefully you can kind of see where we diverged. All right, let's start with the two trig functions. All right, so the first thing that we have is dy dx is equal to sine of x. And so what we need to do to find the antiderivative of that is remember that the derivative of cosine is negative sine. So the antiderivative of positive sine would have to be negative cosine. So this is equal to y equals negative cosine x plus c. And down here in problem number 6, we had 2 times cosine x. And the antiderivative of that is 2 sine x plus c. All right, and so here we were looking for two graphs that have kind of that sinusoidal snaky motion in it, and those are I and D. All right, so let's think about what would lead you to choose one over the other for them. So here, dy dx is equal to sine x. So I'm thinking, when is the slope of this going to be equal to 0? All right, and so sine of 0 degrees is 0 because sine looks something like this. So at 0 degrees, the sine is 0. So where do we have a slope where it's 0 on the y-axis when x is equal to 0? And that is choice I. On the other hand, this kind of looks like the graph of sine x if we were to sketch out a slope field for this. So this is one where the solution is sine of x, and this is one where the slope is generated from sine x. Do you see the difference between the two of them? So here, having sine x as my slope formula is going to lead me to a slope field that looks like this. Here, where sine of x is part of the solution, is going to lead me to one where the graph that I'm drawing looks like sine. All right, so that's D. All right. The next thing I want to do is I want to look at the three parabolas, the three where the derivatives are linear functions. And so we've got here dy dx is equal to 2x plus 4. And here we have dy dx is equal to x. And here we have dy dx is equal to 4 minus 2x. All right, so these are going to be three functions that are all going to have parabolas as the slope fields. So here are the three slope fields that generate parabolas. Once again, I liked asking myself, where is the point where this slope is going to be equal to 0? So 2x plus 4 is equal to 0 when x is equal to what? When x is equal to negative 2. So which one of these slope fields is talking about having a slope of 0 at negative 2? That's this one right here. There's my slope of 0 every time my x value is negative 2. All right, and the other thing we can see is that this is x squared plus 4x plus c. So this is a positive upwards facing parabola, not quite like that, but that's the basic idea of it. All right, so there is my A. Let's take a look at 8. So here is one where dy dx is equal to x. When's the slope equal to 0 this time? Well, when x is equal to 0. So this is kind of the parabolas that are being generated from that slope field. Y equals 1/2 x squared plus c. Once again, it's positive. We can see that this is generating upward facing parabolas, and we can tell here, since the coefficient of the x squared term is positive, this is going to generate positive terms. But you can see the difference between the two of them, that this is going to be 1/2 x squared because the vertex of the parabola is going to be here on the y-axis, and here it's going to be over to the other side. And the last one was number 7. So that's 4 minus 2x. And so since this is 4x minus x squared, this is going to be a downward facing parabola. And when is it going to be 0? It's going to be 0 when x is equal to positive 2. And so you can see both of those things are happening when you look at this slope field, that you've got this downward facing parabola that's coming out of it. And right here, when x is positive 2, you've got that the slope field is flat at that point. All right. Let's see, what else do we have to kind of look at here? Well, looking through the rest of them, let's take a look at this one. So this is dy dx is equal to x squared. So this is going to be a cubic equation. So cubic equations, and it's a positive cubic equation. So cubic equations look something like that. Let's look at what we've got left and see if we can find the one that has that as its slope field. And there is C right there. All right, so that has our slope field looking like this. Once again, we can see that this is going to be flat only when x is equal to 0. Okay, and you can also see that when x is 1 or negative 1, the slope is going to be 1. So that's what we see here and here. Okay, so all kinds of clues in these slope fields. And let's see, what have we got left? We've got 5 and 7 and 10. All right, so, oh no, 7 we already did. 7 was G. All right, and so this one is going to be a quartic equation. So it's x to the 4th power. So this is going to be a polynomial, but it's going to be kind of a weird looking one with lots of curves in it. This negative 1 over x, the antiderivative is the natural logarithm of the absolute value of x plus c. This one might be a little bit easier to recognize. Which one of these would look like a logarithmic function except flipped top to bottom? And that looks like 10. So we can see, if I flip it upside down, this is exactly what a logarithmic function looks like. So that is E for number 10. And notice that this is what we mean when we talk about the absolute value of x. So this is what's happening with the logarithmic function over on the left-hand side of the axis, because you can't take the natural logarithm of a negative number. So we need to throw in that absolute value, or else this is not going to make any sense for negative values of x. And the last example here is 5. And we can see if we draw out the slope table for this, that this is equal to 0 when x is equal to 0. When x is 0, this is going to be flat. This is also going to be flat at, I don't know, -1, -2, maybe -3 there is when it's going to be flat again, and +3. So at +3, this is going to be, well, no, I'm sorry. It's going to be, what is that? That's going to be like x squared. Nope, I'm sorry, that's going to be x times x squared minus 3. So this is equal to 0 when x is 0, or when x is equal to positive or negative the square root of 3. And so you can see that it's going to be flat kind of right about there, and right about there, which is exactly what we see here. So that is H for our last solution. All right, so hopefully that gave you kind of a toolkit worth of ideas for looking at a slope field and a differential equation and seeing if they line up. So that's another one of the important skills we're going to have to face for dealing with slope fields. In the next video, we're going to take a look at the last one, which is going to be almost the same process, except that instead of looking at the differential equation, we're going to look at the solution for the differential equation.